Okay, so let us look into the cadmium iodide structure. In the previous class, we saw the structure of nickel arsenide, and you can just find out the difference between these two. And it is very important that we remember to draw the structure. We get marks in the examination. So here is the structure. You can see that there is a cube there. I'm going to underline that cube here. Keep in mind this cube. Okay, there is this cube there, and there is another cube there also in the top layer also. This top layer cube has got can be converted into some hexagonal structure by means of rotation. Suppose if you number this here, you can see that I'll just number this 1, 2, 3, and 4 here. So these are this one 1, 2, 3, and 4. Now you can see that if you just tilt the cube, this particular thing is going to form a layer like this. Okay. So 1, 2, 3, 4, 5, and 6. I'm just not able to write very clearly. So here again redraw it. Yes, it is. Here it is. You can see that I'm going to get a hexagon there. Okay, hexagon close packing structure. I'm just going to get it. So let us look into what is being said there. In cadmium iodide, the iodine forms a hexagonal close packed structure. Hexagonal close pack arrangement. While the cadmium cations fill of all of the octahedral sites. So cadmium you have to avoid sides. So this you have to keep in mind. The alternate layers. So that is very important. First layer will be cadmium, second layer will be iodine. The resultant structure consists of a layered lattice. That is, if it goes like this, CDI, ICDI, it goes like this, and again it can go like this, ICDI, like this layer is there. But that kind of thing is not present in nickel. It is NiAs, NiAs, NiAs. It keeps repeating for nickel arsenide. So a very important point here for you to remember that the structure goes like this. First layer, second layer, third layer, and then fourth layer. And suppose this is third layer and this is the fourth layer. Third and fourth layer are same here, but it is not the case with nickel arsenide. First, second, third, fourth. You can see that third and fourth layer are different atoms. One is nickel and another one is arsenide there. So the resultant structure consists of a layered lattice. And what is it by layered lattice? So it consists of a layer there. This same structure is found in many other salts in this. Cadmium iodide is mostly ionically bonded but with partial covalent character. So this is general representation of that. And then cadmium iodide crystal structure is the prototype on which the crystal structures of other compounds can be considered and based. Okay, so let us see how we can draw this. So here is the nickel arsenide structure which we saw in the last class. Nickel arsenide. I'm going to draw the structure of the cadmium iodide. Let me see how we can just proceed. So first point, second point, third point, and fourth point here. Fifth point and sixth point. Okay. This way I'm going to write it. So if I join this, 6 lines, we're going to join this. Okay, the first layer that is there. Right? Again, I can just crisscross them. So it's making autocorrection. I'm just trying to do that. So you'll get the first layer like this. Okay. I'm giving importance to drawing because unless you draw it, it's not going to be, you're not going to learn anything, and this is the way of learning. Okay. This thing, representing cadmium there, and this thing representing the iodine there. So I'm just going to draw lines here and here stop with this. See what I'm doing. I'm just drawing more structure like this. Okay, so this will constitute the 6 atoms there. Okay, so now you can see that there is a structure like this. Now in this structure is quite similar to this structure, quite similar about this, but this one is nickel arsenide, so this one is cadmium iodide. And here we saw how these things are connected. These 3 nickel atoms are connected by the form of a triangle. This was a reverse triangle, and so if we drew a triangle like this, we got something an octahedral pattern, right? So if we see from the above these 2 circles, we just superimpose it, we get something like this, right? So then we'll have a structure in which you can have 1, 2, 3, 4, 5, 6, and then we join them, so we get an octahedral like this. Right, so we got an octahedral. So nickel atoms are placed in an octahedral. Now look at what is being done here in this nickel arsenide. That kind of pattern we are not going to find. Rather, we are going to have a layer of another. This is an iodine layer. These are all iodine layers I'm just putting. And I'm just putting another iodine layer here. Here, the center. Then drawing another one here. Then another one here. And then this thing goes exactly in this here. This should go here. So there is another layer that's just quit in between this triangle. You can see this, I can consider this as a kind of triangle. Below this, you are going to have another line like this. So I'm just drawing these lines. Okay, so this happens to be another iodine layer. This happens to be another iodine layer, and this happens to be another iodine layer. But where is this cadmium layer located? The cadmium layer is to be this just in between this. Remember the thing that I drawn CDI, CDI, CD that I gave. Just a minute, I'm going to switch. Okay, so here is the. I'm just going to draw one more thing here. What should I go? Should I put here? Yes, here. Okay, iodine layer here. Or rather, I will put another iodine layer here. See that it is joined together by means of a okay, these two will join with these two. And another, the next iodine layer will be somewhere here and somewhere here. So you can see that I am getting a triangle like this, and I'm also getting a triangle like this, right? So these two triangles, these two triangles, I think again you can put these two triangles like this. You can put parallel. If you put these two triangles, so I think I told you about the trapezium layer like this, but here you can just this is not exactly measured, so you can see the cadmium iodide layer and then another iodine layer here, and then next layer is iodine. This is very important for you, and there is no cadmium layer there, no acidity layer there. Okay, so this particular thing will be called as the layer lattice, and this kind of minus charge for this, minus charge for this, and minus 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 is going to repel, and this results in cleavage. Cleavage means it is going to be it exists like, you know what, you can see that you can just spread them very quickly, and they'll come off very quickly. Okay, the iodine atoms are arranged in HCP layer. So iodine atoms are arranged in HCP layer. This is the point you have to mention. And then the cadmium atoms are present in octahedral sites. That is it. This is the octahedral site. Actually, it should come like this. This and this should be cadmium atoms. There is a cadmium atom there. This is the cadmium atom there. Cadmium atom, they come in the sorry, not I, OH side. These two are very important. Okay. In between the iodine layers, all octahedral positions are occupied corresponding to the molecular formula of the type MX2. And each cadmium atom has 6 iodine atoms surrounding. This is how we have to write. Each cadmium atom has got 6 iodine atoms surrounding it, and that is this one. This is the cadmium atom. This is what I am going to mention here, right? Similarly, each iodine atom has 3 cadmium atoms. Each iodine atom has 3 cadmium atoms surrounded by it. Now you know this structure is of type MX2, therefore CD8 will be there. Into 2 you will get 6, so 6 to 6 will be give 6 corresponding atoms. That means the MX2 type of structure will give you the exact hexagonal close packing structure. Thus, therefore, this is going to give you a layer like this: ICD, ICDI, ICDI, like this, and that is the there are 2 iodine layers. There, the negatively charged iodine atoms, they repel each other, and therefore there is no ion, positive ion between them. Therefore, the compound is called as flaky in nature. Then you know what is meant by flakes, cornflakes, like that. You see small layers of them. The compound is flaky. It can be easily cleaved between the iodine atoms. Okay. The similarity is that in the unit cell of cadmium iodide, you get ICDI, ICDA type of structure, but in nickel, you get ASNI, ASNI, AS, like that type of structure. Okay, so just clear about this. The cubes, they're just small unit cell. Is this one is the unit cell, but if you consider adjacent atoms, you are going to get a hexagon there. 1, 2, 3, 4. This is rearranged, and you have to draw a structure that I have drawn here. This one, a hexagonal layer there. First in the hexagon layer, next hexagon layer, another hexagon layer. In between these 3 hexagon layer, there will be one OH position which is occupied by the cadmium. Okay, that is the main thing that you have to mention. I'll give the description in the YouTube section, and you can make down the points there. But I suggest that you try drawing the structures, because unless you draw it, it will not be very clear to you, and you will never understand this how it fares very close structure with rutile structure. Cadmium structure is the prototype on which the crystal structure of many compounds are done. Therefore, this is very important. Many other compounds are there. Okay. So compounds with any of the following characteristics tend to adopt the CDXT. That is the MX2 type, the flaky structure, um, and the HCP OH pattern that is there. And that is not there in the case of the nickel iodide. There are OH sites in which you have got nickel. Here you have cadmium. That is the main thing. And I just drawn the structure also. So let us just look at the coordination structure, that image that I'm just going to show you there. Just to test. So here is the main difference between these two. See, you can see that there is a cube, that unit cell that is being considered there. This is cadmium iodide. So it's a cube that that is, we can consider this as hexagon also if you have adjacent atoms that come there. But how you can arrange is that inside the cube you got two opposite sides which you can put uh, the iodine structure. I'm sorry, the cadmium. Iodine is large. Iodine is bigger one. Cadmium. These are the cadmium atoms. Iodine is such that. But in the case of nickel arsenide, you will have nickel at the center. This is nickel at the center. Look at this. It is occupied by 1, 2, 3, 4, 5, and 6, which is an octahedra. But here, this is occupied by this iodine layers are occupied in a structure which is iodine is taking the octahedral structure like this. Iodine is taking an octahedral structure like this. So in another picture, I can just show you the comparison there. Just right. Sorry, not this one. Just import. You'll see. Unless you draw it, it's not going to be very useful to you. CDI to this structure. Yes, here it is. Okay, you can see how the cubic structure is going to take up the cubic structure. We just had this cube, right? This cube. So you just draw one more layer there, and you're going to get a cube like this, right? But that is not our concern. In these two cubes, you can see that we have got two atoms there that are in a particular cube. These two atoms. This one will take up this, and this one will take up this, right? So likewise, if you join the four cubes in place, you are going to get a very good hexagonal layer like this. Okay, so that hexagon. So you can see that how cube can be accommodated. Cube can be accommodated for HCP tracking. So this is very important for you. You just remember, you go through this, have a look at this. This is the sharing or the coordination of that particular atom. 1 by 4 means, this atom is shared by four squares. One here, another below, this one, and then fourth one on the right side. See if it is at the bottom, right? 1 by 6 means it is shared by 6 such atoms. So here is the structure that is drawn there. It's cubic structure there. It's cube, but outside iodine you get iodine. So we get that type of structure. Okay. So you just draw the structure, and I'll put the note section in the below the YouTube description. Thank you for joining me. If you have any doubt, just please contact me.